Hi, in this video we're going to consider the situation of two acids. We're going to look at the following problem. 1 liter of water contains 1 mole of HF and 1 mole of HCN, and we're asked to find out how much of each of the two acids have dissociated, and we're given the Ka of HF 6.3 times 10 to the minus 4, and we're given the Ka of HCN 4.0 times 10 to the minus 10. And we see, looking at these two Kas, that the HF acid is a much stronger acid. Its Ka is 1 million times bigger than that for HCN. And that tells us that all the H3O plus that's going to be generated in this problem is going to be coming from the HF. And with that in mind, we'll set up the ICE table for the HF. We have HF plus H2O going to F minus plus H3O plus. We'll go directly to the E line. It's 1 molar, it was 1 liter, and 1 mole was dissolved, minus the amount dissociated. And all the acid is coming from, H2O plus is coming from this reaction, it's X. And so we end up with the expression X squared divided by 1.0 minus X is Ka. And now please pause the video and see if you can solve for the orders of magnitude of all the key terms in this expression. Good. So we can see that the Ka is much smaller. Its order of magnitude of Ka for HF is minus 3. It is much smaller than the initial molarity, which is 0, order of magnitude 0, and therefore we'll assume that X is a very small number, which means the order of magnitude 1 minus X, the X can be ignored, and it will be 0. If we have 0 order of magnitude here and negative 3 order of magnitude here, that means that the order of magnitude X squared is negative 3, and we find then that the order of magnitude of X is equal to negative 1.5. So we have the orders of magnitude. Please pause the video to see if you can use the orders of magnitude to solve for the value of X. Good. So what we have here is that the order of magnitude of X is negative 1.5, and that makes it 1.5 orders of magnitude smaller than 1. And by the 5% rule, that means the X can be ignored. If we ignore this X, if we cross it off, we can just directly calculate for X, and we'll find that X is equal to 2.5 times 10 to the minus 2, a number that indeed is of order of magnitude negative 1.5. And now what we'd like to do is use this information to find out how much HCN has dissociated. So we're going to use this information, and so let me first, we're going to need this key information here, so I'll put it over here, and I'll get rid of the stuff to give us some working space. Okay, so now our goal is to find out how much of the HCN has dissociated. And so we'll do that, but we'll start with the reaction, HCN plus H2O going to Cn minus plus H3O plus. This time we're going to go again to the E line, and we're going to use the variable Y for the amount dissociated. The HCN was 1 mole of HCN in 1 liter of water, so it was 1.0 molar initially, minus Y. And the difference now is the amount of H3O plus. All the H3O plus came from the HF. None of it really is going to come from this reaction, and so we can just use this number here. That's the amount of of H3O plus that came from the HF reaction and just put it in directly right here. 2.5 times 10 to the minus 2. And if we do that, then we end up with the expression that y times 2.5 times 10 to the minus 2 divided by 1.0 minus y equals the Ka. And now please pause the video and see if you can solve for all the orders of magnitude of all the relevant terms. Good. So we saw that the Ka, the order of magnitude Ka, is very tiny for this reaction. It is minus 9.5, much smaller than the initial concentration. And so we can assume that y is a very small number, and therefore the order of magnitude 0 minus y will not be influenced by the y. It will be 0. If we have an order of magnitude 0 here, an order of magnitude minus 9.5 here, 2.5 times 10 to the minus 2 is negative 1.5. And so what should y's order of magnitude be? If we make it negative 8, negative 8 plus negative 1.5 is negative 9.5. So the order of magnitude of y is negative 8. And now see if you can, with this information, solve for the value of y. Pause the video, please. So once again, y is a very tiny number. It's of the order of 10 to the minus 8. It can be ignored in this denominator. If we ignore the y in the denominator, we can directly solve for y, and we find out that y is equal to 1.6 times 10 to the minus 8, which is, as predicted, order of magnitude 8, negative 8. And we see that what we said and assumed initially was true. The HF acid has dissociated 1 million times more than the HCN acid. All the H3O plus in this problem is really coming from the HF, and really none is coming from the HCN. And we'll practice problems like this in the lab tomorrow.